Diabetes and Nutrition, Basal-Bolus Insulin Therapy Calculations from the Diabetes Education Program at the Hospital for Sick Children. This video explains how to calculate a bolus insulin dose using an Insulin-to-Carbohydrate Ratio, ICR, and an Insulin Sensitivity/Correction Factor, ISF. Counting carbohydrates is an essential part of basal-bolus insulin therapy. Please watch our video on carbohydrate counting before watching this one. Please note, the images in this video are for illustrative purposes only and do not constitute the hospital's endorsement of a specific brand or product. Basal and bolus insulin therapy. Long-acting basal and fast-acting bolus insulin therapy are both part of a treatment regimen. This video focuses only on the calculations needed for fast-acting bolus insulin. The fast-acting bolus insulin dose. There are two numbers you will need to work out to determine the total amount of insulin needed for a bolus dose. The carbohydrate dose. You will need the number of units of insulin for the carbohydrates you are going to eat. And the blood sugar correction dose. You will need the number of units of insulin to lower your above-target blood sugar to its target level. The carbohydrate dose. Determining the carbohydrate dose requires a few math calculations. First, you need to count the grams of carbohydrates in the food you are going to eat. Then, you will need to work out the number of units of fast-acting insulin needed to match it. This will be different for every person. For this, you will need your ICR number. The insulin-to-carbohydrate ratio, or ICR, is the number of grams of carbohydrate that 1 unit of fast-acting insulin covers. Your insulin-to-carbohydrate ratio may be different for each meal. Your diabetes team will help you determine your ICR, and it will need to be adjusted over time. For example, an ICR of 10, or 1 to 10, means that 1 unit of insulin covers 10 grams of carbohydrates. To calculate your carbohydrate dose, divide the number of grams of carbohydrates you are going to eat by your ICR. For example, if your ICR is 10, or 1 to 10, and you are going to eat a meal that consists of 47 grams of carbohydrates, then your calculation would be 47 grams of carbohydrates divided by 10. This would give you a carbohydrate dose of 4.7 units of insulin. And now on to the blood sugar correction dose. The blood sugar correction dose is the number of units of insulin needed to lower your above-target blood sugar to its target level. To calculate your blood sugar correction dose, you need to know your insulin sensitivity factor, ISF, or correction factor, and your target blood sugar level. An insulin sensitivity factor, or ISF, is an estimate of how much 1 unit of insulin will lower blood sugar levels. For example, an ISF of 3, or 1 to 3, means that 1 unit of insulin will lower blood sugar levels by 3 millimoles per liter. Your diabetes team will help you determine your insulin sensitivity factor, and your ISF will need to be adjusted over time. To calculate your blood sugar correction dose, subtract your target blood sugar level from your current blood sugar level, and then divide by your ISF. For example, if your current blood sugar level is 15 millimoles per liter and your target blood sugar level is 6 millimoles per liter, your calculation would be 15 minus 6 equals 9, divided by your ISF of 3, would give you a blood sugar correction dose of 3 units of insulin. The bolus insulin dose calculation. Now that you have the two numbers, calculate your total amount of insulin by adding together your carbohydrate dose and your blood sugar correction dose. Using the previous examples, your carbohydrate dose is 4.7 units of insulin. This covered 47 grams of carbohydrates. Your blood sugar correction dose is 3 units of insulin. This is to lower your above-target blood sugar of 15 millimoles per liter to your target level of 6 millimoles per liter. Therefore, your total bolus dose equals 4.7 plus 3 equals 7.7 units of insulin. Rounding the total bolus dose. Doses of insulin are given in whole or half units. When using a half-unit pen, you will need to round the total dose to the nearest whole or half number using the following guidelines: 0.1 to 0.3, round down to a whole unit of insulin. 0.4 to 0.7, round to a half unit. 0.8 to 0.9, round up to a whole unit of insulin. For our example that gave us a total bolus dose of 7.7 units of insulin, we would round the dose down to the half number so that our final rounded dose would be 7.5 units of insulin. If you do not have a half unit pen, round up or down to the nearest whole number using the following guidelines. 0.1 to 0.5, round down to a whole unit of insulin. 0.6 to 0.9, round up to a whole unit of insulin. In our example of 7.7, using a whole unit pen, you would round the final total dose of insulin to the nearest whole number, so that our final rounded dose would be 8 units of insulin. Let's do another calculation. In this example, your ICR is 15, or 1 to 15, and you are going to eat a meal that consists of 47 grams of carbohydrates. 47 grams divided by your ICR of 15 gives you a carbohydrate dose of 3.1 units of insulin. This time, we will use an ISF of 5, but use the previous example's current blood sugar level of 15 and target blood sugar level of 6. 15 minus 6 equals 9, divided by your ISF of 5 would give you the blood sugar correction dose of 1.8 units of insulin. Finally, the carbohydrate dose is 3.1 units of insulin. Your blood sugar correction dose is 1.8 units of insulin. 3.1 plus 1.8 gives you a total bolus dose of 4.9 units of insulin. In our example of 4.9, when using a half unit pen, you would need to round up the final total dose of insulin to 5.0 units. When using a whole unit pen, you would round the final total dose of insulin up to the nearest whole number, again, from 4.9 to 5.0 units of insulin. It is good to know how to calculate your carbohydrate dose, blood sugar correction dose, and total bolus dose. Calculating these doses accurately will help you manage your blood sugar levels. Ask your diabetes team for recommendations on apps or resources that can help you with these calculations. We are here to help. If you have questions or need further tips, please contact your diabetes team.